Welcome to this video on projectile motion. By the end of this video, you should be able to answer questions about the key characteristics of a word problem in a real-world scenario. So the first thing we want to do is I've created this organizer to kind of help us think about what questions are asking and what that means for the characteristics. So let's take a look. So here we have our axes. So we have our y-axis and our x-axis. Okay. This point is on the y-axis, is where the graph crosses or touches the y-axis, so that's called the y-intercept. Okay, and so the y-intercept, a word problem question referencing the y-intercept would ask you how high off the ground did the object start? Somewhere along those lines of how high was the object at the beginning? So remember, there's a couple ways we can look for this. When we're in standard form, ax squared plus bx plus c. Your c is your y-intercept. So you can look at the equation. In the table of values, it's where x is 0. Okay, so that will tell you how high you're starting off the ground. The next point that I want to talk about is our vertex. Okay, so the vertex can tell you a couple different things, and the questions can be asked. The most common question you're going to see is, what was the max height? What was the max height, or how high did the object go? And when it asks that question, it's talking height, which goes straight up and down, so that means that's talking about the y value of the vertex. Okay. Another question that you can see is, when does the object start to come back to fall? Or, when does it start to come back down? So when does the object start to come back down? Or it could ask, similar, how long to the max height? Or when will it reach the max height? And all three of those questions all refer to the x value of the vertex. Okay, so if you're reading a question that says, how long before the object, when will it start to fall, is asking what's the x value here, because our x values are usually time or distance, like how far, okay, and our y values are usually height. Okay. So, there's lots of points on a parabola, but we're really only focusing on the y-intercept, the vertex, and then we're going to look at our x-intercepts. Okay, so both of these are x-intercepts. If one of the intercepts is negative, we're going to ignore it because that's outside the real world. Sometimes we have intercepts at 0, 0. That's still in the real world, so that would count. So this x-intercept Remember, these could also be called zeros. Okay, we're going to ignore if negative because that is not in the real world. So we're just going to ignore it. Now remember, we can have two of them. So on this side, most likely you're going to need to use the quadratic formula to find it. We want the answer in the decimal form, so you're going to simplify it all the way down. Questions that reference this point right here would be how long was the object in the air? Or it could also ask when will the object hit the ground? Or the final question could ask how far does the object travel? Because these first two questions are referencing the time, but it could also be your x value could also be distance, and so that question would be asking how far does the object travel? All three of these questions can be answered by knowing the name of this point, which you'll get using the quadratic formula. Okay, so we have three major points that we look at. We have the y-intercept, the vertex, and the x-intercept. Usually one of the x-intercepts ends up being negative, so we just ignore it. Sometimes it starts at 0, 0, so that's real world. We would still use that one. The last topic I want to talk about here is the other characteristics that get asked about are domain and range. Remember, domain are all of the x values included in the graph. So we're only including x values from the first quadrant. So your domain would be from the origin, so from where x is 0, out to your x-intercept. That's going to be your domain. Okay, so whatever this x value is, and so we'll have 0 is less than or equal to x, which is less than or equal to whatever the x value is for your x-intercept. And your range is a y value, so it's the height value. So your range references this right here. Okay, so the straight up and down. So this comes from where y is 0, and we go all the way up, and it goes to where the y value of the vertex. Okay, so for your y-intercept, I'm going to turn for your range, you're going to say the range is from the ground, we're talking about y values, to whatever the y value of the vertex is. So this is your range. And then your domain is your left to right. Okay, that should answer the majority of the questions that you would be asked about a application problem. So let's try a few, and keep your organizer here and let's reference it. All right, so here we are with our first scenario. Let's take a look. When a cannonball is fired, the equation of its pathway can be modeled by this equation, negative 16t squared plus 128t. Notice there is no c value off the end. When there's no value listed, that value is 0. So I'm just going to put it there to kind of help us look at it for a second. And I have a couple questions here. Find the maximum height. So when I look at my organizer, finding the maximum height, what was the maximum height? That's the y value of the vertex. So I'm going to have to find the vertex. I have the question, find the time it will take for the cannonball to reach the ground. So reaching the ground, well, I'm either talking about this point or this point because here's my ground. So we're going to be talking about the point furthest away. That's when it's going to hit the ground. It's a time question. Okay, so what I like to do is there's no graph here, but let's kind of visualize. This says it has a starting height of 0. So I'm just going to sketch, that's my first quadrant. With a starting height of 0, it's really starting at the origin. Now envision, what does a cannonball do? It's fired and it's going to go up and it's going to come down and it's going to hit the ground. Okay, so I need to know the name of this point and I need to know the name of that point. That's what we're looking for. So it's not a lot different than what we do for just a regular graph. So I need to know the vertex and I need to know the x-intercept. So to find the vertex, I got to start with the x value. So remember, it's the same as the axis of symmetry, the negative b over 2a. So b is 128, so negative 128 divided by 2a. So you have a negative 128 divided by negative 32 is a number, and that number is 4. So now I know the x value of the vertex. To find the y value, you can plug 4 into the equation, or you can put your equation in the calculator to find it. So let's do that. We can use our calculator just like we were doing before. So I'm going to go into y equals, clear this out, and my equation is negative 16. Remember, we don't have t, so we just use x squared plus 128x. I'm going to go look at my table of values for where x is 4, and my y value there is 256. Okay, so when x is 4, y is 256. So that's the maximum height right there. That's as tall as it's going to get. So the maximum height of the cannonball, we said, was the y value of the vertex. So it's 256. It doesn't give a unit, but let's go ahead and say it's feet because that's the most likely unit that they would have measured it in. Usually they tell you what the units are. Okay, now find the time it will take for the cannonball to reach the ground. It starts at the ground, but it's going to go up and then it's going to come down and hit the ground. So I really just want to know the name of that x-intercept. So we're going to use the quadratic formula to find it. We're going to plug in to find the value. It's negative b plus or minus the square root of b squared minus 4 times a times c, and the entire thing is going to be divided by 2a. Okay, so this is what we were doing before. We're going to simplify this, and this is easier to simplify because I don't want to keep the radicals. I want to know the actual numbers. So I want to know what is the square root of that. All right, so let's take a look. The root of 128 squared minus 4 times a times c. So you get everybody plugged in, and it's just 128. So it simplifies down to 128 divided by 2 times negative 16 is negative 32. These guys are like terms. We need to combine them down. So we have negative 128 plus 128 divided by negative 32, and negative 128 minus 128 divided by negative 32. So we have two problems to solve here. Well, negative 128 plus 128 is 0. 0 divided by anything is 0. So really that's this point right here at 0, 0. The second problem, we have negative 128 minus 128, and you got to divide that number by negative 32, and you get a positive 8. So that means the name of this point over here is 8, 0. Okay? The question asked Find how long it will take for the cannonball to reach the ground. So it started here, so for it to reach the ground, we're going to assume this is in seconds right now. So 8 seconds will be the answer to that problem for find how long it will take. Now our domain and range. Your domain is your x. So it's between these 2 points. So it's really always from the origin. So from 0 to 8. That's the only place this graph exists. So 0 is less than or equal to x, which is less than or equal to 8. That's your domain. Remember, your range is going to go this way. It starts at the ground, which is 0, and it goes up to 256. So 0 is less than or equal to y, which is less than or equal to 256. Really, that covers most questions that are going to be asked, so hopefully this is a little bit better than what we were having in class the other day. Let's try another one. When Joey dives off a diving board, the equation of his pathway can be modeled by h equals negative 16t squared plus 15t plus 12. Okay, so we want to find Joey's maximum height. That's the y value of the vertex. How high was the diving board from the ground? Well, that's your c value right there. We can answer that question right there. He's going to start 12 feet off the ground. Look, you've already answered one question. How long did it take for Joey to reach the water? So the water, well, let's visualize this. The water is the ground in this case. This graph is a little different. We started at a height of 0 in our first problem. This problem we're starting at a height of 12. So I'm just going to start the graph up just a little bit higher. It doesn't really matter. And I must say that point is 0, 12. That's my y-intercept. So if we graph this, we're going to see that there's this little tail over here. So we're going to have one negative x-intercept and one positive x-intercept. We only want that positive intercept right there, and we need to know the vertex. Okay, so for the maximum height, we're talking about the vertex here. We need the y value from that. So we started out just like we have. We're going to find the x value by saying negative b divided by 2a. So I get, it's kind of yucky, it's a decimal. I get 0.47 right there. 0.47 is the x value of my vertex. So we're going to plug that into the equation, because if we look at the table of values, we don't have it just sitting there for us to look at. So in the equation, we're going to say negative 16, and t is really our x value, 0.7 squared plus 15 times t plus 12. And what does that number equal? So I want you to put that into your calculator, just like you see it, and you'll come up with, it's a little bit longer decimal. I'm going to round it to 15.5. So right there, my y value, I'm going to say, is 15.5. So what's Joey's maximum height? Well, it's 15.5. Let's say it's feet. It didn't really say what unit to use. We'll just use a unit that sounds like it would be a normal unit for us to use. So 15.5 feet. We could jump to the range right now. We were able to answer it. So the range is from the ground where he's going to hit the water to where he was at his tallest, which is 15.5. So 0 is less than or equal to y, which is less than or equal to 15.5. Okay, so we know all the y values that are on the graph. How high was he started? Well, he started at the 12 feet mark. It's a high diving board. Now, how long did it take for Joey to reach the water? The water's right here, and so that's the x-intercept. So we're going to use our quadratic formula here. So we have negative b plus or minus the square root of b squared minus 4 times a times c, and this whole number will be divided by 2a. So I'm going to start breaking it down. So I have negative 15 plus or minus. Let's find out what that number is going to be. So we'll grab our calculator. And we're going to put the whole thing in. We're going to say the square root of 15 squared minus 4 times A times C, and that number is 31.51. Well, we don't need the whole decimal, so we'll go with 31.51 on that. 31.51, and then whole thing's got to be divided by negative 32. So we're talking about two different problems. One says negative 15 plus 31.51 divided by negative 32. And the other one is negative 15 minus 31.51 divided by negative 32. Okay, so we'll just find out what these numbers are. We have negative 15 plus 31.51. I'm going to say equals, and then divide it by negative 32, and I get negative 0.51. So that's really this point right here. That's not the one we wanted. That one's imagined. It doesn't work. It's not in the real world, so we're going to ignore that one. So our answer is going to come from the second one, negative 15 minus 31.51, and divide that total by negative 32. And I get, we can use 1.45. So the name of this point is 1.45, 0. Okay. So how long did it take for him to reach the water? 1.45, whatever unit, let's say it's seconds. Usually you'll have a unit to work with. Okay. Now for our domain does not start in the imaginary world. It starts here at the origin always. So 0 is less than or equal to x, which is less than or equal to, we go across, and that x value there is 1.45. All right, one last problem. So we have a toy rocket is launched from a platform that is 48 feet high. The rocket's height above the ground is modeled by h equals negative 16t squared plus 32t plus 48. So find the maximum height of the rocket. Maximum height, that's your y value of your vertex. And how long will it take the rocket to return to the ground? That's an intercept when we're talking about the ground. So let's kind of visualize what this is going to look like. Here's our real world quadrant. The rocket starts off the ground 48 feet. It's going to go up, and it's going to come down, and it's going to hit the ground. Okay, so that's your y-intercept at 0, 48. We want to know the vertex, and we want to know the y-intercept. There is going to be a negative, x-intercept. There's going to be a negative x-intercept right there. That's not important to us. It's not in the real world. We're just going to ignore it. So to find the max height, that means I need to find the vertex. So we're going to go negative b, so negative 32 divided by 2 times a. So we have negative 32 divided by negative 32, which is 1. So I know the x value of the vertex. We could put the equation into our calculator and go look at the table of value for ones, or we can just plug it in right here. Negative 16 times 1 squared plus 32 times 1 plus 48. When you put this into your calculator, you get negative 16 plus 32 plus 48, which is 64. So we have 1, 64 is our vertex. So our maximum height was that y value, 64, and it said feet in the problem. So that's going to be 64 feet. Now, how long will it take for the rocket to return to the ground? That means we got to find the intercept. We're going to have to quadratic formula. Before we do that, let's go ahead and answer our range question. We have from the ground, and our maximum height was 64 feet, so it's going to, all the y values are between 0 and 64. And now we'll go ahead and do our quadratic formula. So we have negative b plus or minus the square root of b squared minus 4 times a times c. and this whole thing will be divided by 2a, which will be negative 32. So we're going to start simplifying. So we have negative 32 plus or minus, what is that number? So you're going to take the square root of 32 squared minus 4 times a times c. Okay, and I get 64. Okay, so we're going to put 64 instead of that whole square root number, negative 32. Two problems, negative 32 plus 64 divided by negative 32, and negative 32 minus 64 divided by negative 32. So we have negative 32 plus 64 is 32, which is then divided by negative 32, and you get negative 1. So that was our negative side right over here. We'll try a negative 32 minus 64 divided by negative 32, and I got a positive 3. So that's this intercept on this side. So how long does it take for it to return to the ground? We didn't get a time here, but we're talking about a rocket. I feel like it'd go pretty fast. Let's call it 3 seconds. So 3 seconds for part B there. For our domain, it's from the origin to the intercept. So the origin x value is 0 is less than or equal to x, which is less than or equal to, it doesn't go past a x value of 3. All right, hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.